The double-acting telescopic hydraulic cylinder calculator, from aggressive hydraulics, simplifies intricate calculations and streamlines the design process. Double-acting telescopic hydraulic cylinders are most commonly used in applications that require both pushing and pulling forces and where space constraints are concerned. These cylinders are designed with multiple nested barrels that collapse and expand, allowing for a compact retracted length and long extended length when compared to traditional single-stage hydraulic cylinders. Using our simple web form, the calculator employs proven methods to verify and optimize your cylinder concept. The calculator removes the guesswork from cylinder selection, saving you time and resources while developing your project. To access the calculator, simply visit aggressivehydraulics.com. Select Tools and Resources from the home page. Then click on Hydraulic Cylinder Calculators, and then select Double-Acting Telescopic Hydraulic Cylinder Calculator. The tool calculates extend and retract values for stroke, area, volume, time, rate, and force values for each stage. Also included are area ratio, flow out during extend and retract, and cycle time. Calculations are based on the cylinder parameters of number of stages, total stroke, pressure, flow, outside diameters of each moving stages, and inside diameters of previous stages. Let's quickly review the key terms described in this video. Number of moving stages refers to each section that moves in relation to the main barrel. This tool has the option to select 2 to 5 stages. The total stroke of a telescoping hydraulic cylinder length is the difference between the fully extended length and the fully retracted length. It is the sum of the stroke lengths of each individual stage. Pressure is the hydraulic pressure, measured in pounds per square inch, that is available from the system to the cylinder. The flow, measured by gallons per minute, is the volume of fluid per unit time available from the system. The outside and inside diameter of each moving stage is chosen to meet the application requirements, including load capacity, the available space within the application, and the desired stroke length. Each stage must fit within the previous one. The results of the calculations include approximate stroke per stage, measured in inches, extend area, approximate extend volume in both cubic inches and gallons, extend time, extend rate, and extend force. The same values are also calculated for the retract direction. The calculations also include area ratio, flow out during extend, flow out during retract, and cycle time. Let's put these equations to use by filling out our simple online form. Step 1. Select the number of stages. Step 2. Enter the total stroke in inches. Step 3. Specify the system pressure in pounds per square inch. Typical operating pressures are 2,000 to 2,500 psi. The maximum system pressure can be entered, or this field can be used to determine the pressure required to achieve a specific force. Step 4. Enter the flow rate in gallons per minute. Typical rates range anywhere from 5 to 50 gallons per minute. Again, this could be the maximum available from the system, or it could be used to determine the flow required to achieve a specific time or rate. Step 5. Enter the outside diameter values for each stage. Be sure that each stage is smaller than the previous stage. Stage 1 is the largest stage. Step 6. Enter the inside diameter of previous stages. The main barrel is the largest inside diameter. Each stage must be smaller than the previous stage. Let's review the results based on the inputs the user provided. Approximate stroke per stage, measured in inches. These values are generated by dividing the total stroke by the number of stages. The values are approximate. Actual cylinder design may affect the dimensions. Extend area, measured in square inches. This area is based on the previous stage inside diameter. Approximate extend volume, measured in cubic inches and gallons. This is the volume of fluid required to extend each stage the full stroke. Extend time, measured in seconds. The total time to fully extend each stage from fully retracted to fully extended. Extend rate, measured in inches per second. This is the speed at which a cylinder extends each stage toward its full extension length. Extend force, measured in pounds. The force exerted by the hydraulic fluid on each stage as the cylinder extends or pushes outward. This compressive force is a result of the hydraulic pressure acting on the effective area of the stage. Retract area, measured in square inches. This area is based on the previous stage inside diameter minus the stage outside diameter. Approximate retract volume, measured in cubic inches and gallons. This is the volume of fluid required to retract each stage to the closed state. Retract time, measured in seconds. The total time to fully retract each stage from fully extended to fully retracted. Retract rate, measured in inches per second. This is the speed at which a cylinder retracts each stage toward its full retracted length. Retract force, measured in pounds. The force exerted by the hydraulic fluid on each stage as the cylinder retracts or pulls inward. The retract force is typically low relative to the extend force. It is limited by the stage with the smallest annulus area, resulting in a force 1/3 to 1/10 of the extend force. Area ratio. This is the ratio of the extend and retract areas. The extend side of a double-acting telescopic hydraulic cylinder has more area than the retract side. Flow-out values, measured in gallons per minute. Because cylinders do not have equal areas, when a cylinder is extending a given flow rate, the flow rate out the rod side is lower. Conversely, when a cylinder is retracting, the flow out the cap or extend side is greater. These values are helpful in correctly sizing other components in the system, including valves, filters, and hoses. Cycle time, measured in seconds, is the total time to fully extend and retract the cylinder. If you would like to contact our sales team, the form incorporates a quote request feature in step 2 of the form. Here, the user can provide additional information for our sales team. In the description field, the user can provide details such as application requirements and specific questions regarding the cylinder. Additionally, there are fields for quantity needed and the desired timeline for delivery. Users can also upload files. These files typically include photos, prints, or sketches. The final step of the quote request feature is for the user to provide their personal and company contact information. Required fields include name, phone number, email address, and company information. Once submitted, Aggressive Hydraulics will then process the information and contact the user with the quote. Users are encouraged to reach out to Aggressive Hydraulics customer support for any questions or updates. At Aggressive Hydraulics, our products are engineered to move your business. Our engineering team develops custom cylinder solutions based on your unique needs. We go beyond custom-built hydraulic cylinders to design completely purpose-built solutions tailored to your application. At Aggressive Hydraulics, our products are engineered to move your business.